Is it anyone still coming? Is the rest? I think still got 10 more people. Maybe we start. Did we fix the online replacement today? Today, 6 to 8, is it? Okay, 6 to 8. Then I will send out the invitation link later for the Zoom meeting, the Teams meeting. Yeah. Any question from the last lecture? Have you guys tried out the question I gave? I think I haven't provided the solution yet, but any question on this question? This problem? Have you guys tried? Not yet. Maybe you try first, and then if you need me to explain, I'll explain later. 6 o'clock in the 6 o'clock class. Okay, if you need me to do it. I haven't put out the solution yet. I forgot to put it up. Actually, I have answer to what Ziqian, let me move this back up, asked last time. Okay, about the symmetry of Fourier transform. That is, if you Fourier transform twice the function, the periodic function, what you get is this 2 pi f minus t, right? Okay. So the first question is why there's a 2 pi. Okay. So why there's a 2 pi is because our convention for the Fourier transform. So what's the definition of Fourier transform? Is you integrate negative infinity to infinity of ft multiplied by the exponential function minus I omega t e t. Okay. So in this way, if you look at the Fourier inverse Fourier transform, you get an extra 2 pi factors coming out, where the inverse Fourier transform is taking the I omega t instead of minus I omega t. These are in the lecture notes. Okay, so we are about to see how to deduce the Fourier transform twice property. Okay, so what you can do is really you divide by 1 over 2 pi and then multiply by 2 pi. And then what can you do is you change the variable of minus t to minus t, and then you get this integral here. Okay, so what I did from here to here, right, is I changed variable from t to minus t. So if you change t to minus t, the integration domain change, but you introduce a minus sign, so you swap back the integral domain. Correct. Anyone? Any question? No? Okay. So can everyone see why I just open it. Let's see. Is Hu Yuyan appearing now? Not yet. Still not yet. Okay. Tong Wai Yin. Is Tong Wai Yin? Yeah. Not yet. Okay. Not yet. Seng Yingqi. Hey, I called you before, right? Okay, change another one. 何以何以 Not yet. Not yet. Okay. Now. Who else? 李佳业。李佳业。Okay. Okay, you. So can you explain why this label it? The number first line and the third line is the same. Just refer to why. No idea. No idea. No idea. Why not you ask just now? What do you mean by problem by paper? Any idea? No? Okay. Let's call another one. 实验博. Okay. Prime. Why first line is equal to third line? Any idea? No idea. Why not you ask just now? So if you don't understand what I say, right, please ask. Okay. Please ask. Okay. Don't just let it go. Anyone can explain or not? You don't want to try? Want to try? You sure you want to try? You try? Sure. That's good. Okay. Yeah. Which one? The number one, the one that you mark at number one. Uh-huh. Like the minus I, they got and set the E like negative E, so the negative cancel out. Okay. then that's all. Okay, almost. So what you do is you change a variable, right? So if you apply the change of variable, change from variable to yeah, let me change the variable. So let if you use s equal to minus t, right? So what's this? So similar to what Pichon say, you can just cancel the 2 pi off. And then what you do is you substitute minus t as x. So when t is negative infinity, it becomes positive infinity. When it is infinity, it becomes negative infinity. Okay. And then fx e to the power I omega minus x. So what's dt here? Okay. So you need to compute dx equals to minus dt. So dt is minus dx. Right. Okay. So you got a minus sign here. So instead of minus sign, you can swap the integration interval from minus infinity to infinity. Okay. So you get fx e to the I omega minus x dx. Okay. Which is the same as equation 1. Right. We just change the dummy variable of t to x. Does everyone follow? Okay. Okay. Hello. Right. Does everyone get it? Okay. I mean, in mathematics, right, everything should be clear. Okay. If you are not clear, you should ask. Okay. Please ask. Don't be shy. Please ask. Okay. Okay. Thank you. Okay. Okay. So what's this? What's this here? Okay. So what's this? Okay. You can see that this is quite close to equation 2. This is quite close to equation 2, except the function inside here is a little bit different. Right? Okay. So what you really get is it is equal to the Fourier inverse Fourier transform of another different function, which is 2 pi of f minus t. Right? Does everyone follow? This is from 2. Say again. You mean this one? Left hand side, left. No, no, because of this line. This line here. This line here. This is exactly same as 1. Are you convinced that this is 1? If this is 1, then the left hand side should be equal. Are you convinced that this is 1? First. If you're convinced this is 1, then this is the left hand side you get. Oh, Fs, yeah, Fs or Ft are So this is just a dummy variable problem. How to say it? Okay, so let me ask you another question, okay? So does fx equals to x same as fy equals to y? Are these two the same function? Really, if I want to put s as t here, right? Okay, of course, mathematically it's wrong, but yeah, I shouldn't say more. Okay. Um, yeah, my idea is this: fx equal to x, fy equal to y. Okay, so these two represent the same function. So what we care is about the function. Okay, what we care is about a function, no matter what variable you put in. Ah, you still not happy? Yeah, you try think about it. Try think about it. Yeah, try and think about it. Try think about it. I think this is worth to think this question. But what I can say is this is the same principle as this. Fx equal to x, fy equals to y. You are just changing variable. Okay. Yeah, so I mean, yeah, you really have to have this transition from your high school math, right? So you can't just see um, the step. You really need to see what's the step are doing. Okay. So that's the reason why I call this x a dummy variable. Really, we can just change this t to anything else. All right. Is it clear? Is it clear? Okay. Any more question? No more. Okay. So what we deduce here is f Fourier transform of ft is equal to f inverse of 2 pi f minus t. Okay, but we know that if we do Fourier transform on inverse Fourier transform, we get identity. Okay. In that case, we will get the 2 pi f minus t. Okay. So so what? So yeah. So we got this 2 pi f minus t here. Really, if you change the convention of Fourier transform, okay, if you define your Fourier transform in another way, okay, another convention, so different definition of Fourier transform, let's call it f prime or f theta. Okay, so if we define it in a different way, then we might not need the 2 pi factor, which is minus 2 pi I omega. Okay. If we define it this way, then we might not need the 2 pi. So the symmetry here refers to if you do twice Fourier transform on the function, you get the function reversed in time. F minus t. So the t reverse, right? Minus t. So 1 become minus 1. Minus 1 become 1. So you reverse in time. Okay, it's the time reversal that's important here. The scalar, not so important. If we change the definition, the scalar will disappear. Yeah, the scalar is due to the integration of the exponential function. because I don't want to do the integrals, so I don't want to talk about how these two are coming out. Right? So I just give you this definition of Fourier inverse. First, yeah, Fourier inverse Fourier transform formula. So I start from here. Okay. Any more follow-up question? No? You get it, or you still thinking about it? Huh? You get it? Okay, okay. Yeah. I mean, it's a usual place to get stuck, but you should be unstuck soon. Yeah. Okay. Any other question from last? Okay. Okay. Okay, so we'll keep continue with this calculus with parametric curve. So when we talk about these parametric curves, right, you should always have an example in mind. Yeah, what example in mind you should think about? Circle, good, very good. I think that's the one of the two examples we talk about. Okay, a circle, a unique circle. Okay, a unique circle. So this circle here, how can we describe it? How we describe the circle? What's the circle equation last time? Okay, so let me fix the fix the uh, fix the point first. So it's a unique circle centered at 0, 0. Okay, how we describe this circle here? Remember, it's two ways we can do it. Okay, x squared plus y squared equals to 1. Right? So what's the other one? Using the parametric equation. X equals to sine theta, y equals to sine theta. Okay. So in parametric equation, we introduce an extra variable t. Okay. So you should think of it as a particle running on the circle. Okay. You should think of a particle running on the circle when the time increases. Just out this circle here. Okay. So these are the two way to describe a circle. Okay. So today we talk about tangent. About tangent. So we get tangent on parametric. Okay, so what's the tangent? Okay. So tangent of a straight line should be easy, right? It's just the gradient. So you take a straight line. Okay. What's the tangent? Is the gradient. When you take any 2 points, you get the ratio of the difference of y coordinate and x coordinate. Okay. So for straight line, it's easy. Why? We can pick any arbitrary 2 points to compare. Okay. But for something that's not straight, you need to go to the limit definition. but we will revisit this definition again. Okay, but let's say today we know that so today suppose we know that and y are differentiable. Okay, so first suppose we already know that a and y are differentiable, okay, with respect to t. Respect to t. Okay, so what's the tangent line at that point? At a point. Okay, so what's the tangent line? So let's say we already know that x and y are differentiable. Okay, so we want to find a tangent line on our curve. And so how should we find it? Right. So I'm gonna give you the formula. So let me see. How should I tell you first? So the gradient. So let me label this point as so the gradient dx, okay, is given by dy dx equals to dy dt divided by dx. Okay, so really, I shouldn't write like this. Okay? Did you guys see any problem if I write like this? You mean dsbt? Well, dt. Okay, sure. Let's add that in. So that okay. Still, there's another problem. Okay. Okay, that one is a bit pathetic, but that's fine. So let me move it down. Okay, sure. Okay, there's another problem that I want to say. When we write dy over dx, right, we don't really mean dy divided by dx. Okay. So what I really mean is the following. So I differentiate the function y, okay, with respect to x is equal to differentiating y, the function y with respect to t divided. So this is the real fraction divided by differentiating x, the function x with respect to t. Okay. So d over dx is a operator, is not a fraction. Okay. Sometimes, maybe in OD, you guys did the separation variable, right? Okay. Why you can do that is because they go through the formal definition first, and then they see that actually there's a simple way to execute the calculation. So that's why they move it across. Okay. Actually, in principle, it is a operator. Okay, make sense? Okay. So you should remember that d over dx is a operator on a function, and then give you another function. Okay. So it's a operator from function to function space. Okay. So yeah. So really we need to put a t here if I need. So this is the gradient. Okay, maybe I don't talk about the gradient line first. Okay. Should I add more? Okay, I should add where. So because we need to differentiate y with respect to x, right? So you need to really make sure that y is a differentiable function of x. So that you can differentiate. Okay? Okay. Make sense? Make sense? Okay. So, okay. So let's prove this. So how should we prove this? So let's prove this. So how should we prove this? So you can see that y and x are in terms of t. Okay, we want to differentiate with respect to x. Okay. So there should be some chain rule involving here. Okay, so we should use chain rule. So what is chain rule? What's chain rule for composite function? Well, recall what's the chain rule? Recall chain rule. So for differentiable function f g t, okay, how should we differentiate composed with gt with respect to t? Anyone remember what the chain rule is? F by gt, then g by t. Okay, I think a bit too short. differentiate f with respect to g, right? gt multiplied by shifting gt, differentiate gt with respect to t. Okay, okay. So everyone agree on this? Okay, chain rule. Okay. Okay. So how do we apply this? So how do we apply this? Okay. So what do we get? What do we have? Okay. So in our case, we have three differentiable functions. So we have the it, xt, and yxt or yx. Let's just call it yx. Okay. So how do you apply the chain rule? How do we apply the chain rule? We apply chain rule. Recall what we want to get, right? What do we want to get? See our goal, and then see what we have. Uh-huh. Why? So you can let f to be y. Yx or yt? Yx. Okay, and then g is the x. And then t is due to t. Okay, so let's try out. So d, so Okay, let's do step by step. So let f t be the y-x, okay, and then gt be the be what? The xt. What are you saying? Okay. So what do we get? Let's see. So let's see what we get. So d over dt yx equals to d. Okay, let's try out. I don't know. Let's try. See if we got any mistake or not. If we got mistake, then we need to change something. Okay, so let's see. Let's compare. What do we want? Let's compare what we want first. Let's compare. See any different or not? So you want to divide these terms across, right? Okay. But what is at the top here is yt. How about that answer? Yeah, sure. Okay. So we need to differentiate across. Let's see what's the difference. Yx. Okay. So any difference between these two? Okay. Any different? Can you spot the difference? Okay. Mathematics is like this. There's two things you need to do the mathematics. Actually one thing. You need to spot the pattern. To spot the pattern, you need to spot the difference. So mathematician, I think not the only thing, but one of the things that you need to do at is spot the difference. First, spot the difference. Second, you need to be logical. Okay, now please spot the difference. This is our goal, right? So this is our goal. Let's write our goal. This is our step. So please spot the difference. Any different or not? Where's the difference? Okay, good. So can we fix that or not? Can we fix that? Oh wait, did you hear what he said? Okay, so how do we fix that? Can we fix it? Can we fix it? Okay, I try not to give you the full answer. I try to make you figure out answer yourself. Because this is typically what you met when you do homework at home, right? You always make problem, right? So how do you fix yourself? Anyway, can I change the x to t? So one is y as a function of t. One is a y in the function of x. Can we make it into function of t? I will say the answer is in the slide. In the slide. What are the three things you have? Okay, let me guide you one by one. Sheldon, okay, I haven't seen you in a long time. So what are the three differentiable functions we have in this proof? Given in the question. First line. And y in terms of x. Okay. Okay, y in terms of t, x in terms of t, y in terms of x. Right. Okay. So since you know how to express y in terms of x, and you also know how to express x in terms of t, can you express y in terms of t? Yes or no? Huh? Yes. How? So Venus, how? You say yes. By replacing x in the equation y with t in terms of t. Can you guys imagine? If you cannot imagine, I give you, we go back to this example here. Okay. So we have y in terms of, we have x in terms of t. How to write y in terms of t? What you do is just plugging. Plugging, in other words, okay, we have to be professional with substitution. Okay, so we do substitution, right? So plugging is the right idea. So we do substitution. So we can just write cos square t equals to plus y square equals to 1. Then you can write y in terms of t. Okay. So what we really have here is 1t. Yeah, maybe I say sum x equal to xt. Then we will get t y to t over what? Over d dt xt equals to no. Yeah, I think we are. Okay. Okay, so you need to remember this formula here whenever you want to calculate dy dx, but you are given the parametric equation in terms of t. Okay, make sense? Is it making sense? Make sense? Okay, right?
But it's still doing the same thing. Then you can sub the x to t, but they get the same thing. Because it is original is yx by d.
So your function don't have t, how you differentiate with respect to t? It is a composite function. Yeah, right. Sure. And then so
One of the function on the t, then you get the same thing.
uh um okay. That question is, I think, equivalent to say why we use chain rule. I already settled that problem already. I just want to re-express my y of t. Your question is exactly why we use chain rule. My problem is I just want to express my y of t. Yeah, you get what I mean? Composite function already differentiating composite function already settled by chain rule. So what I'm doing here is I'm just express my y in terms of t. That's all. I didn't do anything special. Yeah. Okay. Yeah. So my question is just I want to express my y in terms of t so that I can differentiate with respect to time. Right? If respect, I mean, if I give you this if I give you this xy function, how you differentiate with respect to t, then no t here. But you know that x is controlled by t. So you need to make that expression apparent before you can differentiate. Okay. Okay, maybe take two questions. So before we take a break, then we'll do calculation. Two questions. So last time, for those who didn't come last time, so we have a game. Everyone should ask at least one question. So every hour I will take two questions. It can be a simple question. It also can be a concept question. For those who already asked, can give chance to the other. Maybe we take from that row. That row is quite quiet. The last the third row. I know you change rows, so you're not counted. So for those in the back, for those at the back, we'll take two questions before I take a break. Third row, please. Question. We'll sit here for 10 minutes and then we'll restart it. You also can ask some obvious question if you want to check your concept. Yeah, okay. Mhm. Correct. Yeah, yeah, right. Yeah, that's right. Okay. One more. Yeah. Mm-hmm. Hey, this is a good question. This is really good. So why not we just straight away differentiate with respect to x? Is this your question? Yeah, this is a good question. Right. Why don't we just straight away differentiate with respect to x? Okay. So one problem I said just now is, if you are given a parametric equation in terms of t, right, then the most straightforward way is to use dx over dt and dy over dt. But let's say you have y in terms of x. Can you straight away do that? Okay. The answer is yes. But again, in our setting of parametric curves, right, you can see that this is not a function. Okay. So this is not a function. You cannot straight away differentiate. Okay. Maybe you can use implicit differentiation. Okay. Maybe you can use implicit differentiation. But another one thing you need to note here is this is still not a function. It's not a function. Is it a function? So yes, that's right. Yes. So yeah, that's right. So in the theorem, we need it to be a differentiable function. So since this is not a differentiable, how can you make sense of it as a differentiable function? How to make sense of it? Very good. I glad that some of you see this problem. Okay, so how do you make sense of this as a differentiable function? So you can either squeeze your domain or your codomain so that it represents a function. Okay, because in the end, this tangent line, right? We only care about the local information. Okay, so we can reduce our domain or codomain to the part where it is a function. Does it make sense? Okay, we don't need to look at the whole curve. We can just restrict to a domain or a codomain so that it is a function, and then you can do differentiation. Is it clear? Maybe let me draw something out so that you can have something to imagine. Right. So we can restrict our domain maybe to this part, 0 to 1 on the x-axis, and 0 to -1 on the y-axis, so that this part is a function. We can do differentiation. Make sense? Okay. Yeah, we can always restrict our domain, codomain, so that it represents a function. Okay, make sense? Okay, so let's take a break until 12:05. Then we'll come back. 12:05.
Okay. Tangents of actually not a differentiable function. Like some circle x square plus y square equal 1. Just an example.
Yeah.
So when we want to find its tangents, we must squeeze its domain.
Yeah.
Otherwise, we can't conclude.
Yeah.
I just asked. Then you set the problem.
Yeah. That's right.
And even
Mm.
even this one equals 0, it can actually imagine line that is some vertical line satisfies this function.
Sure.
And when this equals 0, it also can set a horizontal line.
Yeah, sure.
Satisfy this.
Sure.
But I can't imagine why when these two things all equal to 0, what line I get?
Oh, and yeah, that is. Yeah, so I mean you you are just asking when is a curve, where is the point, what kind of curve, what kind of point have dy dx equals 0, right?
Yeah.
So first of all, it is the maximum or minimum point. You have dy dx equals 0. And then yeah, yeah, one of the point is maximum or minimum. The critical point, dy dx times 0. Yeah. But there are more points which are dy dx equals 0. So for example, those let me think. Yeah, I can't recall now. But I think when you do exercise, you'll see it. Yeah. Yeah. You want to see?
Yeah, I want to ask for some help about the project.
Okay. Where's Li Kai? You know Li Kai? Yeah. Oh, it's weird. Thank you.
Assignment.
Oh, assignment 1.
This equation is that.
Hmm?
It's my assignment 2. It's for I bigger than j plus k. This is the permutation of negative number. No, this is the time of negative number, and we made number very, and this is next to the like minus k, and this is not 0. Although I know this term is 0, but in terms of this function, this is not 0. Yeah, but we have to show it for all I. So it's not right.
Let me see. Let me see. How should I put it? Hey, are you the one who messaged me?
No, I think it's not me.
Someone team messaged me. Li Kai or someone?
But not me.
Not you.
Yeah.
Okay. I will explain this one. I'll explain this one. Maybe I want to make this clear.
Okay.
I want to make this clear.
Thank you.
Okay. Linh Wu.
Hey, does anyone know where is Li Kai? Li Kai. Where's Li Kai? He has always been like on time every time, but this time he's not there. Huh? No. Huh? Where?
Other assignment.
Other assignment.
Yeah.
Okay.
So can I get the full definition of your dx earlier? Think about the
Yeah.
no, dx.
Didn't define dx or dx is another thing. A different dx. Okay. I also haven't
Because
defined
it's
that.
like by the formal definition, you can multiply dx.
Because that one is a theory of one form. One form.
We will learn in partial.
I'm not sure in this course you will learn. I don't think you will learn this.
Okay, then I will write it in my.
Huh? You're writing a project?
I think
It's called differential form.
I think I'll do the exact and then I'll probably put that
Oh.
in as well.
Okay. It's a differential form. You can search differential form. Those are called one form. So you are integrating over one form.
That one I also need to use it, right?
Yeah, I think so. Yeah. Basically, they use that.
I'm gonna start soon. Please be ready. Please. Start soon. We're gonna start soon. Okay, for assignment 2, right? I think a lot of you asked about this question. This part here. I think a lot of you confused with this. Okay, so really, okay, this I derivative, right? It only makes sense until x to the power 2k. Okay, if you look at this function alone, okay, if you look at this function alone, this function is a polynomial function, right? Is it? Okay, you can imagine bunch of xk, and then the highest degree you can get from this part is also sk. So sk times sk is x2k, x to the power 2k. Okay, so this is the highest power you can get. So beyond that, this derivative is just 0. Okay, so you should make sense of this I derivative when k, okay, when it is less than 2k. And then, see what's going on. I mean, k is fixed. K is already fixed. Okay. And see here. So when K, okay, now you want to fix I to be what? K, okay, I is K plus 2, and then here is K, sure, okay. So you need to differentiate up to K plus 2 times, good, okay. So, okay, you should see that if you differentiate until K plus 2, right, every term below K plus 1 are all 0. Is this what you care about? So if you happen to see any negative thing or what, you should think of it when you differentiate this guy. Okay. If you differentiate, take I equals to K plus 2. So the K minus the K plus 1 below terms are all 0.
But that term is not correct. So we need to make I smaller than K, but not too big.
Wait, let me see. Okay. Let's say what I say first, and then I will deal with you individually. Okay. So if you think that some of the term doesn't make sense, right? You should think about the original differentiation. Okay. So if you differentiate, for example, if you differentiate 2K plus 1, okay, so this term should be 0. Okay. So anything doesn't make sense here by convention need to send to 0. Does it make sense? Okay. So when you solve this question, right, you should always keep this polynomial in mind. It's okay. If you can't see it, you just fix K to be some small number first. Maybe 3, 2. Okay, and then see what you get for F1, F2, F3, F4, F5, and so on. Okay. Anything doesn't make sense here, should send to 0. Okay, this is the comment I made. If you want to challenge me later, 6 p.m., tune in to Teams. Okay. Okay. Later I'll deal with you. Okay. Is it clear to the rest? Clear to the rest? Try and work it out. See what I say is true. Okay. 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 So we will skip one of the example in the lecture notes. So one of the example is look at the curve defined by x equals to 5 cos t and then y equals to 4 sine t. T is in between 0 and 3. Okay. So find dy dx. Evaluate it at t equals to power 6. And then the other one is compute the second derivative at the same point. So this one, we will skip this and the next one. Okay. So we have do another question that has more context. So this one we left as homework. So I discuss another one with more context, where we actually can draw some. Okay, so let's look at another curve. If I forget to put those solutions that I left with homework, right, please remind me. Sometimes I just forgot. Just now I try to write down so that I can remember when I see it. Hey, hello. What are you guys discussing? Okay, so let's look at this curve. So this is a curve defined by two parametric equations. Okay, so x component is controlled by t, y component is also controlled by t. Okay, so first part. So let's show that this curve, let's call it C. Let's call it C. Let's show that C has two tangents at point 30. Okay, and find their equation. So what does this asking about? So they want to find two tangent line. Okay, so two tangent line. If I tell you the gradient of the line, do you know how to make equation of line? What's the formula for equation of line? Let's recall. Equation of line. So what's the equation of line? Huh? Ooh, y to the mx plus c. Okay. I think this not very helpful, right? Because you need to find c. So there's another more general way. What's the more general one? Equation of line. What do you need? What's the ingredient you need to make a line? You need a point lying in the line and also the gradient. Okay, so a more general equation of line is y minus y1 equals to m times x minus x1. Okay, yeah, so I use this. C, you need to go and find the y-intercept. If you are not given, so how to find y-intercept, right? Okay, but in this case, we know that we want to have the point 30 on the tangent line. So let's get the gradient out first. So how to get the gradient? So, okay, so when you solve this question, right, you should think about it, what you are doing first, okay? So you have a curve running on the xy plane, okay? At the moment, I don't know how it runs. Maybe I just draw a generic curve. So now we want to find at the point 30. Okay, let's say 30 is somewhere here, right? 30. Okay, meaning it have to touch 30, is it? Yeah. So that means my curve should really touch 30. Not just once, but twice. Makes sense? Okay. So maybe I go here and then I turn around maybe, okay, like this. Something like that, I don't know. I just simply draw. But we need to have two tangent points. So meaning we need to pass by 30 twice. Okay, make sense? Make sense? Right? Okay, so now we need to find dy dx, the gradient. Okay, so when we ask about tangent, right, is asking about gradient on xy plane. Okay, good. Okay, continue. So now we are given two parametric equation. So, but we want to find dy dx. How? we given x in terms of t, y in terms of t, but we want to find dy over dx. So how? Use what we have proven. So which is, what's the formula? dy dt over dx dt. Okay. So what's dy dt in this case? dy dt 3t squared minus 3. What is dx dt? 2t. Good. So we just divide 3t squared minus t over 2t. So what do we get? We just get this, right? Good. Okay, so what's next? So we need to check on the point 30, right? So you can see that this point expressed in terms of what variable? This point lie in what plane? XY plane, okay? But our equation is in terms of, our parametric equation is in terms of t. Okay, so we need to find what time the particle passed by the point, right? Okay, so we need to check when x equals to 3, what happened to our time? Our time is plus minus square root 3. Okay, and when y equals 0, what happened to our time? Our time is t times t squared minus 3 equals to 0, which is t equals 0, t equals to plus and minus square root 3. Okay, so what does this time mean? So when t equals to plus minus square root 3, the s coordinate passed by 3. Okay. But when time equals 0 and plus minus square root 3, the y coordinate passed by 0 3 times at this time. Okay, so you want the point to pass exactly at 3, 0. So what is the time you need? Plus minus square root 3. Okay, so since xy equals to 3, 0, we need time equals to plus minus square root 3. So when t equals 0, what happened to the time? And what happened to the x when t is 0? Okay, so that means when t equals 0, the particle pass by the origin. Okay, good. Okay, so we have these 2 points here. So these 2 times they pass by the particle pass by 3, 0. So we need these 2 times to compute our dy dx. So at the first time, so minus square root 3, our dy dx is equal to, so we just sub the number in, and minus 3 over 2 times minus square root 3, which we get minus square root 3. Okay, and then at t equals to square root 3, what do we get? We get 3 times square root 3 squared minus 3 over 2 times square root 3, which is just square root 3. Okay, yeah, so we get good. So I got this 2, but we need the tangent line as well, right? Okay, so we need tangent line. So we need 2 tangent line. So the first tangent line, okay, first tangent line. So tangent line at 0. Okay. So when t goes to -3, okay, what's the tangent line? Y minus y1 times dy dx at t equals to minus x times x minus x1. Okay, so in this case, our x1, y1 is our 3, 0. Right, we want to pass by this point. Okay, so we'll sub it in. So y minus 0 equals to the gradient evaluated at time equals to minus square root 3, which is what? Minus square root 3 multiplied by y minus 3, x minus 3, sorry. So you get y equals to minus square root x minus square root 3x plus 3 times square root 3. Okay? Is it okay? So far? So far, so good. Okay. Similarly, you can compute for t equals to square root 3. Okay. So it is the same point you need to pass by, but now the gradient is square root 3. Then in this case, you get y equals to square root 3x minus 3 times square root 3. Okay. Straightforward, is it? So what does this mean? Okay, so maybe we will get a new picture now, right? So let's see what kind of new picture we get. Okay, so from the information we know just now, this particle have to pass by the origin. Okay. And then at this 3, 0 point, you have these two tangent lines. Right? You have these two tangent lines. Okay. So our first tangent line is y equal to minus square root x. So y equal minus x. The direction is what? What's the direction? It is the a straight line cutting across the second and fourth quadrant, right? So maybe we can put this down. Y1 equals to square root 3x plus square root 3 times square root 3. And then similarly, we can put when times equal to, sorry, maybe instead of label this, we just use time is easier. Then t equals to square root 3. Okay. Yeah. So you can see that somehow this particle, right, need to, so time goes from negative to positive. Okay. So let's pass by this tangent first. And then when time equals 0, maybe it pass by like this. And then maybe I don't know what's going on. And then maybe it go like this. Okay. Is it okay? Okay, so from these three information, maybe we guess for now, this is the curve. Okay, so next part. So next part, we can find where the point on C, where the tangent is vertical or horizontal. Okay, so let's say we want to find horizontal tangent. Any idea on how to find horizontal tangent? Or maybe, do you know what a horizontal tangent is? So the tangent line should be horizontal. Okay, so you can imagine the curve is like something like this. Okay, so what happens if you have horizontal tangent? Gradient equals 0. So here we have few gradient here. So which gradient you are talking about? We have to be precise a bit. So which gradient you want to talk about? dy dx or dy over dt or dx over dt? Which gradient? Okay, first of all, dy dx have to be 0. And second, we have to know that dy dt is actually 0. Okay, we are not moving on the y direction anymore. But we are moving in the x direction. Okay, so we have few conditions here. Okay, we have few conditions here. So maybe we can take dy dt equals 0. That dy dt equals 0. Okay, let's do this. I think this one easier. So let's set this. So dy dx, dy dt equals 0. So what's dy dt? We already computed, right? dy dt is 3. Forgot. Dy dt 3t squared minus minus 3. Okay, set this equals 0. Okay, then we will get t equals to Brian. You have something to say? What? I mean, okay, compute this. Plus -1. Just -1. Positive. Okay, positive and -1. Plus and -1. Okay, plus and -1. So at these 2 points here, what do you have? You have horizontal tangent. So not that this is just a time, right? Okay, we want to know the position in x, y as well. Okay, so we can sub the times back to our equation. So when times equals to 1, what is our x? That's the formula. Let's bring this formula down. Okay, so x is equal to 1 squared. Y is equal to 1 cubed minus 3 times 1. So x is equal to 1, y is equal to minus 2. Okay, so when time equals to 1, this particle pass by 1, 2. Y at t equals to 1 is 1, 2. When time is equal to -1, what do we get? We also get 1 on the x coordinate, and then y we get 2. Okay, we get 2. So when it is t equals to -1, we get 1 and 2. Oh, here we got -2. Okay, good. So how about vertical? How about vertical tangent? So how about vertical tangent? Dy dx go to infinity. Okay, good. Can. But we need something computable, right? We still need something computable. What else you can say? So dy dx actually go to infinity. Can everyone see why dy dx go to infinity? How? Okay, I see you not have. So how? The line is close to infinity. Any line is close to infinity. Or the tangent line. I mean, my question is how to see the tangent. I mean, how to see the gradient is going to infinity. How to see? Is there an easy way to see? No. Okay. Okay. Oh, okay, yeah, sure, okay. Yeah, so my argument is similar to that. Okay, my argument is similar to that. So we know that this y equal to x, right? Y equal to x line. Okay, so this gradient is 1, right? And then you can increase it, y equals to 2x. Okay, and then 3x, 4x, 5x, 6x, 7x. So you can see that this gradient is approaching infinity. So your theta is, are you mentioning this theta here? Yeah. So it's similar. Okay. Yeah, one easy way to see. Okay, so I mean, we need something computable. Anything else? So we are moving in y direction, but not in the x direction. Okay, so we should have a dx dt equal to 0, but still moving in the y direction. Okay, so we need to set dx dt equals 0. So what's dx dt just now computed? We get 2t, 2t. Yeah. So we got 2t equals 0. T is equal to 0. So when is t equal to 0? It is at the point 0, 0. Okay. It's at the point 0, 0. Okay, good. So what do we have now? We have more information now, right? So let's see. So we have more information now. So at the point 3, 0, we have two tangent lines. Okay. So one is at t minus square root 3. The other one is t equals to square root 3. Okay. And then we have some vertical and horizontal tangent. So let's draw the horizontal first. So we have 1 minus 2 and 1, 2. Okay. So 1 minus 2, where is it? So maybe we plot here as 1, here as 2, here as minus 2. Okay. And then we got horizontal tangent here, okay, at this point. And then horizontal plane at this point. Yeah. Maybe I use another line. Here, 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 twice. And twice, maybe I make it thicker here. How about vertical tangent? So vertical tangent at 0, 0. So we got another tangent line on the y-axis. Okay. So to piece this together, right, we really need the time factor in. So when t equals to 1, it is 1 minus 2. So here is t equals to 1. 1. And then here is t equals to minus 1. Okay. Okay. So can anyone want to guess what kind of path you will get? So here is t minus square root 3. I think t minus square root 3 is less than minus 1, right? So I need to go from here to here, and then go to 0, and then go to 1, and then go to square root 3. And then you need to meet this tangent line. So, okay, let me give you more hint. Maybe, okay, I cannot give you hint. So, you want to guess? Anyone want to guess how you join this point together and then meeting the tangent line? See, have a guess. So here is a t equals 0 time. Yeah. So you got these 5 points here, 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 and then here. So here and then here, here. Any guess? Any guess? Simple, want to try? Huh? Try it? Let's try. Any guess? I mean, just guess something makes sense. Yeah. I don't know because okay, how you should guess is because it's horizontal, right? Either is at here, either at here. So either is at the top, either at the bottom, right? Either at the right to the vertical tangent or left to the vertical tangent. Either on the top or bottom, right? And then either on the left or right, and then the left or right. So how to draw such that it makes sense? Okay, I mean there's a lot of possibility you could try, but we'll keep continue. Okay, let's keep continue. So let's keep continue first. So part, yeah, yeah. Let's do part C. So determine, determine where the curve is concave upward or downward. Anyone still remember concave upward and downward? I'm not sure you guys still remember. Anyone still remember? Okay, so what's the condition you need? Let's recall it. Okay, so you need to compute your second derivative. When it is concave outward, what do you need? Bigger than 0. Okay. When it is concave downward, it is smaller than downward. Downward. Concave down is less than 0. Okay, so what is concave upward and downward means? So I want to draw the diagram. So concave up, so it's like this. Concave up. And then concave down is like this. Okay. Because dy d square d square y dx square less than 0, you will find the maximum point, right? Then d 2y dx square greater than 0, you will find the minimum point. Okay, okay, okay. So let's see where this this curve concave upward or downward. So we need to do the second derivative. Okay, so now this is a real business here. So how to use second derivative? I only tell you how to differentiate, how to do dy dx, right? So how you extend dy dx to d square y dx square. Dy dx is our y2. So you mean, so okay, let me write out what you're trying to do. So you say let, so you want to do like this? Is it? Okay, and then how? Say again. So the numerator is dt, and then oh dy2. Oh, sorry. So you mean so dy dx, then dx. That's right. Okay. Yeah, that's right. This is the easiest way. If you want to go the original way, you also can. Okay. So what have we computed? We have computed dy dx, right? I still remember what dy dx we computed. 3t cubed minus 3 over 2t. ds dt we also computed. 2t. 3t squared. Okay, yeah, squared, correct. Good. Okay, so how to differentiate this? You need to use, okay, I don't want to use quotient rule, okay? So let me split them term by term. So that I just use the linear property. So I get 3 over 2t minus 3 over 2t. Okay, I think this one is easier to differentiate. Where you get 3 over 2 minus 1 3 over 2 t squared. Is that right? Please check my calculation. Okay, so in the end we get 3 times t squared plus 1 over 4t cubed. Okay, so get this. So when this term, okay, let me move a bit. So when does this term d squared y dx squared, when does this term greater than 0? When is this term greater than 0? When does this term greater than 0? Huh? T greater than 0. Why? Huh. Mm-hmm. Hey, good. To be positive, right? So you can see that the numerator is always positive. So always control the sign is the denominator, right? So if the time is positive, then t cube is also positive. If the time is negative, then the t cube is negative. Okay, so good. So let me write down. So since the numerator t squared plus 1. Okay, I don't want to write numerator, just write since t squared plus 1 is always positive. Okay. So d squared y ds squared is greater than 0 if t is greater than 0 and it is less than 0 if t is less than 0. Okay? Yeah. Okay. So yeah. So what can we do from here? Can we try to do anything from here? Repeat the diagram again. Copy. And then paste it here. In. So let's summarize what we have. So t greater than 0, we have d squared y. Okay, let me take it this one. D squared y ds squared greater than 0. So greater than 0 is concave up or down? Concave up or down? Up. Concave up. Good. So if concave up doesn't mean anything to you, right? You should remember the diagram like this. Okay, concave up. Okay, concave up, you go up. Okay. So t less than 0, you get d squared ds squared less than 0, where you concave down. Concave down. So you go like this. Okay. Concave downward. So you need to somehow split the time interval into these two parts. Okay. So when time is less than 0, it goes from the bottom up and then going down. Okay, going back. And then when t is greater than 0, it goes from the top to bottom and up again. Okay, so you need to put this basic shape, try and fit it into here. Okay. Okay, so let's try one. Let's try one. Okay, so when t equals to -1, right, you have to concave down. So we can only pick this one, right? Only can pick this one, concave down. Okay. When time is equals to 1, it is concave up. Okay, so we need to throw another possibility away. Right? Make sense? Okay. So now here, these two are pretty confirmed, right? We need to make these two a bit longer. Okay. So so I don't think you can go around like this, because otherwise you will meet another horizontal or vertical tangent again. So we need to throw this away. Okay, otherwise we will introduce more horizontal or vertical tangent. Okay, so maybe let's draw this. Okay, so how to do the rest? So how? Okay, so when time is square root 3, right, you have two directions here. And you have two directions. You can go either this way or this way, right? So, but you also note that when time is greater than 0, it is always concave up. Okay, you won't concave down anymore. Okay, so you will just keep going up, keep going up, keep going up. Okay, so maybe you will throw this guy up. Similarly, you can do it for time equals to -2, where we throw this guy up. So in the end, we will have okay, so this is our curve, space curve. Okay, the curve moved by the particle. Yeah. Any question? Any question before we take a break? Finish already, right? Isn't it 1 o'clock already? No, I mean break until yeah, yeah. I'm not professor here. Don't call me professor. Okay, thank you very much. Yeah. Yeah. Okay. So, any question before we break? Any question before break? Yeah, this question come out in your assignment, right? Find the horizontal tangent. What kind of question do we still have? Did we already cover all the? We still have these. Hopefully, we can do this tonight. Otherwise, extend the deadline. You guys want to extend the deadline? Yeah. Which day you guys? Okay. One thing to take into consideration for this assignment, right? Because you guys have a test on the week 7. Okay. So I think it's better you guys can take feedback before the test. Right? So we can extend, but we can extend too long. So currently it's on Tuesday, right? Okay. So which day you guys want to extend? Friday, yeah. I mean, okay, so the exam will be on the next Friday. Next Friday. 1 week before. I also need to mark, right? Yeah, I also need to mark. So how long I take time to mark? I mean, depends on what kind of solution you give me. Yeah.
Unless not collaborate, then you are 80.
What's AG? No. I mean, you can collaborate, but you need to write your own answer. That's all. You can collaborate. Whole class can collaborate, no problem. But you need to write your own answer. Yeah. So if it's the same answer, then it's plagiarism. So let me think. So Friday, right? Because I meet you on Wednesday, so I do mark before Wednesday. Oh, one. Yeah. Too rush for me. I mean, Thursday is a holiday, right? So I assume if you want to work, okay, how much do you guys left first? Oh, you haven't started the assignment? No, I mean, just be honest with me. Right? Haven't started. Okay, so you got 2 holidays. One is the Monday, one is the Thursday. Okay, so I give you work until Thursday midnight. Thursday midnight,
No problem.
and then I will see you Friday for class. Right? Okay, so I don't want you to think about the assignment again on Friday. So I extend until Thursday midnight. Okay. What? Are you the class monitor? Who? Class monitor. On team 4. Oh, it's a real class monitor. Oh, what's this? Formal or what? Every class should have a class monitor or what? No? Oh, it's not formal. Okay. But what did he do for class monitor? Oh, he created a group. I see. Okay, so anything if you want to complain about me, you can talk to him and then he will tell me. Okay. Okay. Yeah. I mean, 1 minute different, is it? Yeah. So 1159 here. 1159 here. As a user. Because then and then I will send out the crop mod link soon.
Okay, no problem.
No problem.
You also get
Okay, thank you. Okay, before you leave, come here and sign your attendance.